Right, Mr. Simon, promised you to make a video before closing down the gearbox, and this is the point where I'm at now. I've composed both shafts again. Actually, there's 3 shafts. I'll explain that in a minute. I've completed all the things that I wanted to do, which basically meant changing all the bearings. They're all new apart from this one. Didn't change this one because the one that they sent me had way too much play, and this one's actually still okay. To give you an idea of what kind of bearings we're talking about, this is the kind of bearing we're talking about. They cost about €100 a piece, and this one has partially melted, as you can see. It's partially completely gone on this side. That is because very likely the gearbox has overheated, which I had to grind it out in order to get it off of the shaft, and that was probably has overheated because of a lack of oil. So it was also leaking oil, very probably through the main front seal, so it changed that as well. And here's the 2 rear bearings. As you can imagine, of course, the gearbox carter closes down this way, and then there's another carter that goes at the back, and this is basically the output shaft. The shifting mechanism goes in that direction. Basically consists of a lever that operates these 3 rods that you can see going in here. So this is the top of the gearbox. This is the actual shifting mechanism. So what you do is basically a pin down here when it's in the middle. When you shift down to first gear, you basically move the pin in this section, and then when you push forwards to select first gear, you're basically pulling this back because that is it is inverted. And this this selector sleeve basically operates this synchronizer sleeve, which is then pulled towards this synchronizer ring. So there's a moment of friction whenever you're shifting gear, and there's a difference of speed between the input and the output shaft because we're now in neutral. As you can see, none of the gears are selected, and of course it moves a little bit, but there's basically no direct connection between the input and the output shaft because the gears, they're all spinning freely on the axle. So basically there's no direct connection between any of these gears and this shaft. They're spinning completely freely. In order to transfer the power, what you're basically doing is you're pulling this this ring, this selector sleeve, which has teeth on the inside. They're pointed teeth. And as you can see on 5th gear here, you're basically going to engage this selector sleeve on this dog ring, basically it's called. And because there might be a difference in speed that needs to be resolved in order to synchronize the speed that this ring is turning at and this gear is turning at, in order to synchronize it, there's the synchronizer ring. As you can see, the synchronizer ring, this is a rather worn out synchronizer ring. You can also see that there's not that much surface anymore over there. You can see where the selector sleeve has worn out this ring, and the surface has been consumed, which is not too much of a problem because, as you can see, these rings, they're split. They're not completely round. And basically, I'll show it to you in a bit. What it does is whenever you are creating that particular kind of friction, there's a couple of breaks in here, and they expand the ring so that the ring expands within this sleeve and creates even more friction in order to resolve the speed difference. As soon as the speed difference is resolved, these pointy teeth, they're on either side, so they're on the side of the gear and they're on the side of the selector sleeve, they basically shift over each other. I can show it to you. For example, I'm trying to apply 3rd gear, which is of course now extremely dry because there's no oil in it whatsoever. I'll need both hands to do that. Anyway, as soon as you do that, I'll do it in a minute. Click. So that's third gear. I've now selected third gear, which is basically what you do when you shift into it. And as you can see, there's now a connection. So basically what happens is the power flows in here. These two are always connected. This is the input shaft. The shaft ends here. This is basically, there's a bearing, a roller bearing inside that in order to allow it to turn freely. And it always transfers its power to this lay shaft. Okay, so it's basically the correction gears for the main shaft on them. And what happens now is that the power basically flows through these gears onto the output shaft. So that's what happens when you select a gear. There's a beautiful mechanism inside there in order to avoid you selecting multiple gears at the same time, because that would be devastating, because the entire thing would just lock up. And then there's reverse gear here. There's a pinion that is basically on an axle on the other side of the carter that sits in here, that reverses the speed. And that's basically how a gearbox works. So I'll deselect third, select very neutral again. There we go. Of course, it's extraordinarily dry because I cleaned it all up. As you can see, there's no residue on it anymore. What I've done is I've changed the synchronizer ring on second gear. This is second gear. As you can see, the surface is completely different. You see there's quite a bit of meat on those rings instead of, for example, fifth gear. You see the difference? The difference is rather big. That's because on these gearboxes, usually the second gear is the one that's used the most, because they had a very stupid design for the first gear, which I'll try to replicate. Some of the parts that I still have left over. Those are some old bearings, some old seals. Where are my straps? Probably throw them away already, haven't I? Oh no, I put them here, of course. Explain to you what a gear looks like on the inside. This is the old synchronizer ring from second gear that I replaced. And basically, so we're looking at a gear from the selector sleeve side. So what happens is inside the gear, there's these little components. These are the straps that I was talking about. So what happens when this, because of the friction, moves towards this pinion and this engages on the gear itself, then of course these two come into contact and there's going to be tension between the two. And this brake section is going to actually expand the synchronizer ring, so that it exactly rubs against the selector sleeve. Even when it consumes the surface, this mechanism is going to make it work anyway, until we reach a point where there's literally no surface left, or the selector sleeve itself has completely worn out on the inside, because that also happens. And as you can see, they've made a terrible design. This was the original design for first gear. You have to imagine that usually it is completely the same on either side, so it must be completely symmetrical. This one isn't, so I had to create a custom design for first gear instead of just using whatever they already used in all the other gears, which is of course much more expensive to do. And basically what happens is it only synchronizes on one side, because on the other side, whenever you did that basically that section was going to rub against the gear, and there's going to be no expansion whatsoever. So it only synchronized on the downshift, so when you were shifting down from second to first. That is when it was engaging, because it had to speed up. Okay, so whenever you're shifting from second to first, you have to increase the speed of the input shaft. And you're going to say, so well, then what sense would it have to upshift into first? But that is basically what you're doing when you're going from neutral to first. So whenever you're in neutral, the main shaft, so the output shaft, is sitting still because the wheels are not moving, and this section is moving at the engine speed, so at about 1000 RPM. Whenever you are shifting into first, you're disengaging the clutch, so this is still turning because it has momentum, and you're going to select first gear, so you're going to rub the selector sleeve on the synchronizer ring of first gear, because it was missing this piece, it wasn't engaging. So basically what was happening, which is also what happens when you, for example, shift without the clutch, is you're not giving the synchronizer rings the possibility to synchronize out the speed difference, and these pointy teeth of the dog gear are going to rub against the selector sleeve, and they're going to eat each other up. As you can see, these are a little bit worn out. You see, they're not dramatic yet, as you can see, but they're not as nice as, for example, fourth gear, which is here. First gear is actually even worse. Second gear, sorry, is even worse, because these gearboxes were designed whenever you wanted to shift into first from neutral, you first have to dip into second, thereby wearing out its synchronizer ring even more. And then you had to select first. But if you didn't do that, you're going to wear out these teeth. So luckily, mine isn't in that bad of a shape yet, thanks to my shifting abilities, because I usually double clutched when, for example, shifting from first to second, thereby saving the synchronizer rings. So basically what I wanted to stress is the importance to shift slowly, which means do not forcibly select a gear. You have to give these synchronizer rings the time to sync out the difference, and then it'll just pop into gear. If you don't do that, you're gonna wear out the surface on the synchronizing rings as well as the synchronizer sleeves. And if you don't give it the time to properly sync, you're gonna wear out these teeth, which is actually worse because this is a very expensive component to change. They cost about, for my car, they cost about 300 euros each to change these teeth on the inside. The gear itself, of course, it's a high point gear. That makes it very silent. There's constant friction between these two surfaces, which is of course corrected by a very thin oil film that resists these very extreme pressures that exist within the gearbox. They also serve as not only as a lubricant but also as a coolant, because that is what keeps the gearbox at the right temperature. And therefore it's very, very, very important that the gearbox is always at the right oil level, which is very hard to check because you really have to be underneath the car and you basically have to pump in oil until it comes dripping out on the input hole. Then you know there's enough in. In my case, it has been leaking. I didn't actually know it was the gearbox because it was leaking out of the front, and it was just dripping down the bell housing and dripping out the rear of where the engine's attached. So I thought it was actually the rear seal of the engine itself, but it was actually the gearbox. So that's what actually nicked me and led me to having to do this incredibly complex job. But it's actually quite nice. I can definitely recommend it. And the fact that it makes this a constant mash gearbox is that all the gears, the actual gears that transfer the power, apart from the reverse gear, they're always into contact. So it's not as if you are selecting these particular gears. They're always all into contact. It's only just that they are spinning freely on the shaft. So you have to connect the shaft to the gear through these dog gears by applying a selector sleeve to it. So that's how a gearbox works. I hope this was interesting and you haven't fallen asleep yet. Please do let your wife and your daughters know as well, because it is going to be incredibly important, especially from products from Italian manufacturers. I've had some experience with Fiats. They happen to have very weak gearboxes to shift slowly with their 500 in order to preserve the actual gearbox. So, well, have fun with it on Easter. Bye.